Hello students, welcome back. In the previous video, we studied the probability mass function. Now let's study cumulative distribution function. This is a definition of the PMF, and that's the definition of the CDF. The probability mass function is the probability where the random variable capital X taking the numerical value x, small x. So capital X equals to small x. Whereas the cumulative distribution function measures the cumulative probability where the random variable capital X takes a value small x or less. So capital X is less than or equal to small x. So it's cumulative probability. In practice, it goes like this. On our model, we have 5 red, 3 green, and 2 blue balls. And we have RGB as a sample space, and we can assign appropriate numerical values to make it a random variable. And here's one. Red is 0, green is 2, blue is 3. Here's another way. Red is -1.5, green is 0.5, blue is 1. Here's a third way, and of course there are many more, infinitely many more, but let's keep it simple. Let's consider these two. If we have time, this one as well. Okay, what is the PMF here? The probability mass function. We have these 3 possible values, 0, 2, 3. Those are possible outcomes. And the probabilities are 5/10, 3/10, and 2/10 respectively. And that part is the core part of the mass function. And then here's a graph. 0, 2, 3, and the probabilities of 5/10, 3/10, 2/10. Those are heights. If you don't like this horizontal table form, you can use vertical table form like this, and that's going to be useful if you have something like 14 lines. If you have 14 boxes horizontally, then you're going to run out of space, but vertically, it's better. It's more versatile that way. And if you have this vertical, then maybe you can extend from here to there. Pretty much okay in piecewise defined form. Now this is for a student who are strong at algebra only. And let's see. Yes, this is a graph. And now let's consider the cumulative distribution function. Cumulative distribution function. So you have to accumulate probabilities, and here's the preparation. These 3 numbers, 3 possible outcomes, x equal to 0, 2, and 3, divide the number line into 4 pieces. X equal to 0 here, red, x equal to 2 here, green, and x equal to 3, blue. And these 3 points, colored points, red, green, blue, that correspond to RGB outcome. Those 3 points divide the number line into 4 pieces. X is less than 0, between 0 and 2, between 2 and 3, and finally greater than or equal to 3. Now, those 4 pieces, that's easy. Now, where is the semi-inequality? Semi-inequality always go to the left. Not less than or equal to 2. Less than or equal to 0, only here. Not less than or equal to 3 here, no, that's strictly less. Semi-inequality goes only to the left. And let me bring up the same analogy that I used in week 1 and then used again in week 2. If you scored precisely 90 in this course, do you deserve A or B? You should be getting an A. You should go to this interval here, top interval. If you scored precisely 90, this should be 90 or higher. If you scored precisely 80.0, should be getting B or C. You just earned B. You should be in the second interval here. And same goes over here. If you had precisely 70.0, then you should have earned C and passed the course successfully, not B. Okay? So use that, and you will not forget Semi-inequality always goes to the left, and through these 4 intervals, we can assign cumulative probability. First, everything begins from 0 because less than 0, there's nothing. No point here, over here, so no probability. So the cumulative probability is 0. Now, here the second interval here. How many big dots to the left? There's only one. So that is less than or equal to, well, any x I can select from here. And that probability is 5/10. 5/10. What if I select from here? It's cumulative probability, so I have to add up. First from 0 and add up this and add up that. 5/10, 3/10. If I select from here, then keep adding up. 5/10, 3/10, 2/10. Eventually they'll add up to 1, and that's gonna be it. Now, if you're not really comfortable with this kind of expression where we have starting from 0 to 2 and then 2 to 3 and then this one start from 3 but no end, and if you're getting a little bit confused, then maybe you can artificially you can include infinity in here. And same goes here. Negative infinity. Nothing is equal to the infinity, so everything should be strict inequality for infinities. That's not a problem. So you can write this into that form. Always you begin from 0 and end up with 1. So how many squares do we need here in this table? We need 4 intervals, as you can see in this diagram here. We have 3 points, 0, 2, 3. So we need 4 intervals, 1, 2, 3, 4. So we need 4 boxes. First interval, second interval, third interval, fourth interval. And then at each box, you just add up the probabilities. Start from 0 always and end with 1. It's just cumulative probability. Now, if you run out of those boxes because this table is too long horizontally, or if you just prefer to work with vertical table, you can do it like this. Vertically, it's the same thing. And of course, if you're not really comfortable with all these, then you can artificially include infinities as well. Okay, let me put these infinity in gray so that you can easily see that you can discard it if you want to. Or you can use the piecewise defined notation here. The same thing. And this one, well, my advice is try to avoid it unless you know what you're doing. And if you're strong in college algebra, if you liked it, and if you like these piecewise defined notation, go ahead. Some students may have already taken calculus. In that case, you should be familiar with all these and must have worked out a lot. In that case, probably no problem, but the majority of the students just taking stat, tabular form is going to be easier to understand, either horizontal or vertical. Finally, here's a graph. Let's bring back this tabular expression. Let's see. Yep, let's get this thing back. Okay, we have these 3 numbers correspond to these 3 points, red, green, and blue. So we have 4 intervals there. So we have 4 intervals, less than 0, between 0 and 2, between 2 and 3 and greater than 3. We have probabilities 0, 5/10, 8/10, and 1. And those are the heights 0, 5/10, 8/10, and 1. The difference here, the jump, is the mass function. 5/10, 3/10, 2/10, that corresponds to this, and that. Here, if you subtract this from that, what do you get? You get this blue. So that's the jump. If you subtract this from that, what do you get? You get this green, and that's this jump here. If you subtract 0 from this, what do you get? You get this red, and that's this jump here. You can easily see the connection between one and the other. Let's see, do we have time for another? Let's try. I don't know if we can finish, but let's try anyway. Let's look at the second problem here. Negative 1.5, 0.5, and 1. We have these three numbers. So we have 3 points in a number line, and those 3 points will divide the number line into 4 pieces. Let's begin with that visualization. And it's here. See? 4 pieces. And here, for convenience, I disregarded the scaling. Negative 1.5 to 0.5 and distance from 0.5 to 1 are not the same, but I don't care. This is just for diagram purpose. It's not a graph. So with these 3 points and then 4 intervals, as you see over here, okay, less than negative 1.5, between negative 1.5 and 0.5, and so on and so forth, where semi-inequalities are always to the left. And then you can accumulate probability here. Always begin from 0 and then add up the probability for red, so add up 5/10. Next, probability for green, so add up 3/10, adding up, and another accumulation, and that's the end. Add up to 1, the full probability. So eventually we end up with this. So this addition yields that. Or if you prefer vertical tabular form, it's here. And all those intervals are here. And then just add up, add up, add up, add up, and we end up with these probabilities. Same goes for these piecewise expression. And finally, here's the graph. Less than negative 1.5, nothing there, so that's 0. Let's see. Okay. And between negative 1.5 to 0.5, probability is 5/10, so steady at 5/10. And then between 0.5 and 1 here, the probability is 8/10, so steady at 8/10 horizontally. Finally, greater than or equal to 1.0, constantly 1, so horizontal like this. As usual, left-hand side endpoints are included. So if you just made it here, you earned an A. If you just earned here, you just earned B, not down here. Just ended up here, you just earned C, not D down here. And then each jump corresponds the mass function. 5/10, 3/10, 2/10, respectively. So that's how you get cumulative distribution function. And the third problem here, I'll just leave to students. This one, I'll just leave to students.